Hello. Today we'll be discussing the 2025 F equals to ma problem 9. Problem states as follows. N circles in a plane CI each rotate with frequency omega relative to an inertial frame. The center of C1 is fixed in the inertial frame, and the center of CI is fixed on CI minus 1 for I equals to 2 to n as shown in the figure. Each circle has a radius Ri equals to lambda times Ri minus 1, where 0 is less than lambda is less than 1. A mass is fixed on Cn. The position of the mass relative to the center of C1 is R of t. For the n equals to 4 case shown, which of the following statements is true? During the time interval from 0 to 2 pi over omega, the magnitude of acceleration of mass on C4 is, and there are some options. What they're basically asking you to do is to describe the magnitude of the acceleration of the mass on C4. So let's analyze this question. What this part about lambda means is that really all they're trying to say is that the first circle is going to be bigger than the second circle, is going to be bigger than the third circle, and so on. Or that the circles are just decreasing in size, in simpler words. And that the center of CI is fixed on C minus 1. Like as we can see here, C2 is on C1, right? The center of C2. Then the center of C3 is on C2, and so on and so forth. So we're going to attempt this problem. Let's see how to do it. Okay, you're probably wondering, how are we going to solve this problem? It looks really complicated, right? Well, it's really not. Okay, so it's given that each circle is moving with an angular velocity of the same amount, omega. And this omega is with respect to a sitting point, or a point that's stationary. What does this mean? This means that I'm going to be writing it as theta of omega of O2 with respect to O1, where O2 and O1 are like both representing the entire circle. Because I don't want to be using like omega of omega 2 with respect to omega 1 equals omega, or that might be a little bit confusing. So while I know that this isn't the typical convention, it's a little bit easier to explain my work. Anyway, omega theta of omega of O2 with respect to O1 equals to omega, which means if O1 is the standing point, the entirety of O2 is rotating with the speed of omega. O3 with respect to O1 also equals omega, and O4 with respect to 1 also equals omega. However, as we've discussed in previous videos, summing up velocities would mean something like this, and this also applies to angular velocities, so watch carefully. Velocity of b with respect to a plus velocity of a with respect to L equals velocity of b with respect to L. This can be also applied in this instance for this problem as well, as this would imply that since omega theta of O2 with respect to O1 equals omega, and theta of O3 with respect to O1 equals omega, this means that theta of O3 with respect to O2, O is just 0, right? Because we can just apply the same formula. And in the same way, theta of O4 with respect to O3 is also 0. What does this mean then? This means that with respect to C2, C3 isn't really rotating, so it's really just a rigid body. And the same thing with C4 and C3, meaning the C1, C2, C3, C4 is really just an entire rigid body. And as for C2 with respect to C1, this would also hold position, as C1 itself is also stationary. It's also rotating. It's just its middle center that's stationary, so it's also not rotating. So what does this really mean? This mass m that was discussed in the problem, it's sitting on a rigid body where all of these masses are rotating with angular velocity of omega with respect to a stationary point of an observer standing outside, but in reality, all of these points with respect to each other is just forming a rigid body, and m is just moving around a giant radius which looks something like this around O1. And if m is moving in a circular path, that means that its acceleration is constant, as we know that the angular acceleration when moving in a circle is constant and it's always towards the center, meaning that we have that the acceleration must be constant, and in this case, this would have been answer A,